So the whole idea when you're working through to set up and solve for this is you just need to identify what trig ratio relates to the information that's presented. Okay, so when you're looking at this triangle right here, you have an angle. With respect to this angle, you have two sides. You have an opposite and you have a hypotenuse. So which trig ratio relates opposite and hypotenuse? Sine. So katoa, so the sine of theta is going to equal the ratio of opposite 28 to hypotenuse 32. And what you can do to calculate this is the angle itself can be calculated by taking the inverse trig ratio, in this case sine, of the given ratio. And so when you perform the calculations, you get your solution. This is in degrees. Again, make sure you read the directions carefully. And so if I took the inverse sine of that ratio, 28 over 32, I'll put a decimal in my entry so it displays as a decimal. I get 61.04 degrees for my angle measure. So second problem, in terms of you have an angle, you have an adjacent leg and a hypotenuse. That relates which trig ratio? So the cosine of theta is equal to adjacent over hypotenuse. To calculate theta, we take the inverse cosine of that ratio, and that's going to give us our solution. And so here, when you're calculating, we are in radian mode, so we need to make sure we change to the correct mode. Okay, and take the inverse cosine of 11 over 39, put a decimal so it displays as a decimal. I get 1.2849 as my solution. Okay, and then the final example here, with respect to my given angle, I have an opposite leg and an adjacent leg. So opposite and adjacent is, relates which trig ratio? TOA, tangent. So the tan of theta is equal to opposite 17 over adjacent 15. To calculate theta, we take the inverse tan of that ratio, and that's going to give us our solution here. Also in radian mode, so I can stay in my radian mode. The inverse tan of 17 over 15, enter a decimal, and when I do, I get 0.8478. For my solution.